Websites are about to get insane. Chrome just shipped a new API that blurs the line between a website and a video game. It is called HTML in Canvas. It allows you to take any HTML element, a button, a form, an entire web page, and draw it live inside of a canvas, something you could not do before. Now, I know that doesn't sound like a big deal, but trust me, after you see these demos, it will. This is a portfolio website, and that is a real HTML form. I can select the title with my mouse, just like any other text on a web page. The buttons work, the sliders work, I can click, draw, and even write in the text input. But all of this is happening inside of a canvas. The form is painted onto a piece of cloth in a 3D scene. When I click poke or pet, the cloth reacts like real fabric, and the form blends along with it. And when the character walks into it, he crashes right into it. Or check out this HTML range input turned into a jelly slider. You don't have to go full 3D to use this API, by the way. You can also use it to enhance already existing websites. Take this input, for example. It is a real HTML input and I can type on it. But when I submit the form, because it is inside of a canvas, we can apply cool effects to it. Or this form. It looks pretty normal, but the focus effects on the inputs, the way the borders move, the way it glows, all of that is a shader running on a canvas. And when I submit it, a shader distorts the HTML. Or check out this animation that burns the page away when switching between light and dark mode. And this one is just beautiful. Someone built Apple's liquid glass on the web. How cool is this? Imagine all the awesome websites we're about to build and how the web will change. Websites that feel less like a 2D page and more like a video game or an art installation. That is the kind of web that just opened up. So how is any of this possible? As we know, the Canvas HTML elements allows us to manipulate the pixels inside of it. It is incredibly powerful. We use it for games, image editing, 3D scenes, anything where we need pure visual control. But Canvas has no idea about other HTML elements. Let me show you what I mean. Let's say you want to put a simple button on a canvas. You cannot just drag the bottom element and put it inside. The canvas does not understand that. So instead, you have to do all this. First, you paint the rectangle and the text. Then you listen for clicks on the entire canvas and you check if the click happened inside your button's coordinates. Then you do the same heat test again for mouse hover, just so you can redraw the button in a different color when the mouse moves over it. And after all that, you still don't have a real button. You have a drawing of a button, but no accessibility, no keyboard support, no CSS styling, nothing. Now imagine doing this for every button of a page, every input, every form, an entire interface. That is why for so long you had to pick a canvas full of pixels or a web page full of HTML, and never both at once. Every demo you just saw, the cloth, the burning page, the liquid glass, all of them with real HTML underneath used to be impossible for the exact same reason, until this API. Here is what makes all of this possible. The HTML lives in two places at once. In the DOM, when there is a real button that you can click, or a real input you can type into, and in the canvas, where it is just pixels. Pixels a shader can grab, twist, distort, blend, or even map into a 3D shape. Two copies of the same element. One you can touch, one you can paint with. And the API is surprisingly tiny. First, you tell the canvas to opt in by adding the layout subtree attribute and putting the HTML you want to draw inside of it. Then you grab that element and call draw element image on the canvas context. You give it the element and the coordinates, and the canvas paints a live copy right there. If you are using WebGL, there is a text element image 2D, and if you are using WebGPU, there is a copy element image to texture. Same idea, just feeding the HTML into a GPU texture instead of a 2D canvas. And whenever the HTML inside of the canvas changes, like an input getting focused or a button getting hovered, the canvas fires a paint event. You listen for it, and inside of it, you do whatever you want. Paint the HTML, distort it with a shader, or wrap it around a 3D shape. That is almost the whole API. To really understand it, let's build something with it. Here is what we're going to build. A simple button with a reflection underneath. The button is real and clickable, and the reflection is painted by the canvas. First, the HTML, a canvas with a button inside. The canvas has the layout subtree attribute, so it knows about its child. The button is just a plain HTML button, nothing canvas about it. The CSS is also just plain CSS, a pink rounded button. On hover, it turns from purple and grows a little. On click, it shrinks down. Now the JavaScript, the whole thing. First, we grab three things from the page: the canvas, the brush we paint with called context, and the button. Then we say three numbers. X and Y are where we want the button to appear on the canvas. H is the button's height. Now the render function that we call 60 times a second. First, we wipe the canvas clean every frame. Otherwise, all the drawings will pile up. We tell the brush to bookmark its current state. Then we mess with the brush. We tell it to paint everything moved down a bit, flipped upside down, and a 30% opacity. Then we stamp the button onto the canvas. Because the brush is in flipped, faded mode, the stamp comes out as faded, upside down copy of the button. Then we tell the brush to go back to the bookmark. Normal again, not flipped, not faded. Now we stamp the button again with a normal brush. This is the one viewers click on. But here is a problem. The button actually exists in two places. The canvas, where we just painted it, and in the DOM, where the browser keeps the real, invisible, clickable button. The browser does not know where on the canvas we painted it. So when you click on the painted button, the browser might miss the real, invisible one sitting somewhere else. We need to move the invisible one to match the painted one. Lucky for us, draw element image helps. When we called it, it gave us back some math that says where it painted the button. We hand that math to the button style transform, which moves the invisible button to match the painted one, and now clicks land. And finally, we ask the browser to call render again next frame, like pressing replay. That's the whole demo. A real, clickable HTML button painted into a canvas twice. Same element, both copies live, in about 20 lines of JavaScript. But here's where it gets fun. Since the button is on the canvas now, we own its pixels, which means we can do anything to them, like a ripple effect on click. And the code to add it is just this. We listen for clicks on the button, and when one fires, we call ripple at the click coordinates. The ripple function itself is just classic canvas math, something AI can help you with, sampling pixels, shifting them around, nothing new about the API. The point is, once your HTML is on the canvas, you can do anything to it. Now, the honest part. This API is not ready for production yet. It leaves behind a flag in Chrome Canary. So people need to enable it in the browsers for the API to work. And the whole thing is still a proposal. So everything you just saw is still a draft. The names, the signatures, and even the basic shape of the API could still change. So not something to ship into production tomorrow, but absolutely something you should start experimenting with today. I hope this ships for real, because I think it could make the web fun again, like it was in the Flash days. 오늘도 감사하고 사랑합니다. See you in the next one. 다음에 봐요. Bye bye.